Welcome to my presentation. This presentation is part of the playlist Integral of Logarithmic Functions. In this presentation, we will be solving some example problems related to logarithmic functions. Let's look at some examples. Let us evaluate a function integral x plus 3 divided by x squared plus 6x plus 7 dx. We're going to use the logarithmic rule to solve this example problem. We're going to substitute u as equal to x squared plus 6x plus 7. That is in the denominator of the example problem. Let u be equal to x squared plus 6x plus 7. Since u is a function of x, we can differentiate the function u with respect to x. Therefore, du by dx is equal to d by dx of x squared is 2x, d by dx of 6x is 6, d by dx of 7 is 0. So therefore, du by dx we can write as 2x plus 6 as shown here. We can also write this as du is equal to 2x plus 6 dx. So the dx in the denominator, I brought it to the side of the expression 2x plus 6 here. So we can also express, if we want to express it in terms of dx, we can write as dx is equal to 1 over 2x plus 6 du. Now, we can substitute u as equal to x squared plus 6x plus 7 and then dx as equal to 1 over 2x plus 6 du into the given example problem and then use the rules of integration and then solve this example problem. Okay, our example problem is x plus 3 divided by x squared plus 6x plus 7 dx. So x plus 3 is in the numerator. We didn't change anything there. Instead of x squared plus 6x plus 7, we're going to replace that by u, as shown here. And then instead of dx, I can write 1 over 2 plus 6 du, like that. Okay. Now, x plus 3 divided by u times 1 over 2x plus 6. 2 is common, so I pulled out 2, and then I can write this as open parenthesis x plus 3 close parenthesis, like that, du. So as we can see here, we have an x plus 3 in the numerator, x plus 3 in the denominator. Those terms cancel out. We are left with 1 over 2, which is a constant. We can pull it outside of the radical term, outside of the integration term, as shown here. And then we are left with 1 over u du inside the integration term. So therefore, we know the rule is stating that integral 1 over u du is equal to ln of u. So I can write this as 1 over 2 ln of u plus c, where c is a constant of integration. We cannot leave our solution in terms of x, in terms of u. We need to express it in terms of x. So therefore, wherever we see u, we're going to write x squared plus 6x plus 7 as shown here. So therefore, we can write this as 1 over 2 ln of ln of x squared plus 6x plus 7 plus c, where c is a constant of integration. Okay, this is the way we want to solve example problems which involve logarithmic functions. Let's look at another example. Let's say we want to evaluate this function integral 1 over x ln of x dx. Okay, so we are going to use the logarithmic rule to solve this example problem. We're going to let us substitute u as equal to ln of x. U as equal to ln of x. Differentiating u with respect to x, we have du by dx is equal to 1 over x. The differential of ln of x is 1 over x, right? So therefore, du is equal to 1 over x dx. So if I have to express it in terms of dx, I can write this as dx is equal to x du. So now we can substitute u as equal to ln of x and dx as equal to x du into the given problem and then use the rules of integration and then solve this example problem. So when we do that, this is how it's going to look like. Our example problem is integral 1 over x ln of x dx, right? So we have integral 1 over x. The first part I wrote it as is, and then 1 over we are then left with ln of x. So 1 over we said let u be equal to ln of x. So that's what we did here. So ln of x, we wrote it as u, and that is, since that is in the denominator, I wrote it as 1 over u, and then du. Um, Instead of dx, we can write it as x du. So that is what this x du is about. So now, as we can see, we have an x in the numerator, x in the denominator, so those terms cancel out. Therefore, when we simplify it, we are left with integral 1 over u du as shown here. So now we know from the rule that integral 1 over u du translates to ln of u plus c, where c is a constant of integration. So we want to be able to express our solution in terms of x and not in terms of u. So therefore, wherever we see u, we're going to write it in terms of x as shown here. So, but we started to say that let u be equal to ln of x. So therefore, we can write this as ln of x plus c, like that, where c is a constant of integration. So this is the way we want to be able to solve example problems related to logarithmic functions. In my next video presentation, we will be solving more examples related to logarithmic functions.